Alright guys, we're going to move to section 1.4, and in this video we're just going to look at examples where you just combine like terms. And you're going to do this throughout the whole year for Algebra 1, so it's very important that we understand this. Take this down, like terms. Like terms are obviously terms in an expression that look similar or like. You could say if you're dealing with variables, they have the same variable and they have the same exponent. I'll give you an example. If you had, let's say, 3x plus 5x. These are like terms because they have the same variable of x. Now, what I mean by exponent is, now x, the exponent's assumed to be 1. You're never going to see it written that way. So since they're the same, you can combine it. If you did 3x plus 5x, you could just add the coefficients. So 3 plus 5 is 8, and then you keep the x. That's kind of like the basis of what you're going to do for combining like terms. The other thing I have here, put this as well, constants are also like terms. Those are just numbers. Like if I had 6 plus 7. Well, obviously I know I can combine them, even though they don't have variables. 6 plus 7 is 13. Alright, so let's just apply that. We're just going to do 1, 2, and 4. So really what you'll see is, when you combine like terms, you'll see the directions. It'll just tell you to simplify. Alright, so let's zero in here. Alright, let's look at 1. Now it says identify the like terms. So I have 3 terms here, 3x, negative 5, and 6x. The only terms that look similar, meaning that I can combine them, are the 3x and the positive 6x. So I group those together, 3x plus 6x. Then I'm going to put the minus 5 off to the side. I can combine these. So when I add the 3 and the 6, I get 9, and then I just bring down the x. Then I bring down the 5. Now we're done here. This is our answer. The reason why I can't subtract 5 from the 9x, the 5 does not have an x. Those are unlike terms. Once you're left with terms that are all unlike, then you're finished. So I started out with 3 terms. I ended up with 2, so therefore I simplified. Okay, let's move to number 2. Alright, number 2. So you can see I have 2 variables here. I have an m and I have an r. So I'm only going to combine the like variables. So if I circle the 9m, the only thing I can combine is the 7m. Real important, don't forget the negative before it. So when I combine those, I'm going to have 9m minus 7m. Well, 9 minus 7 is 2, and then I just keep the m. So I'm going to have 2m. So I'm going to cross those out because I'm done with it. Then I have the r's. So I'm going to circle those at positive 3r, and then don't forget this negative before the 5r. So when I combine those, I'll write this off separately. You're going to have positive 3r minus 5r. Real important, don't forget the negatives. So then 3r, 3 minus 5 is negative 2, and then just bring down the r, so it's minus 2r. Then we don't get 0 for this because I can't combine it because I have different variables. These are unlike terms, so we're done. Okay, let's look at number 4. Now, number 4, we have 4 terms, and again, we're going to have 2 pairs of like terms. Let's first look at the variables. Okay, if I have positive 4x and I have negative 4x, well, if you do that, 4x minus 4x, that gives you 0x, and 0 times anything is just 0. So these just go away. They just disappear. So there's no x's involved. Then these are like terms. This is the other part of the definition for like terms. These are constants. So I can combine these. 12 minus 16, that would give me negative 4, and that's the answer. So that's an example where you had variables, and the variables could cancel out. All right, so that's just basic, the basic idea of combining your like terms.